Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to look at the general form of the null solution that has complex roots. So complex roots. In other words, what we're going to look at is when we have a y double prime plus b y prime plus c y equals 0. And remember, then we had a characteristic polynomial of a s squared plus b times s plus c equals 0. And we solved this, and we said that s1 or s1, s2 is equal to negative b plus or minus the square root of b squared minus 4ac. Well, not only that, divided by 2a. Well, you have complex roots. This occurs when b squared minus 4 times ac is less than 0. In other words, you have a negative under the radical that's going to produce an answer that has I. So what I'm going to do is then notice that we're going to have two possible answers. We're going to two possible answers. We're going to have two possible solutions. Let's just say that the solutions here are S1 equals A plus I times B. Well, remember that complex numbers come in pairs. They come in conjugate pairs. So that would mean that S2 is going to be A minus I times B. So let's try this. So now we can say that this is our null solution is going to be some C1 e to the parenthesis a plus I b t plus C2 e to the a minus I b t, like that. Oh, watch this. So this becomes C1 times, well, e to the a plus ib times t. This becomes e to the at times e to the ib t plus C2 times e to the at times e to the minus ib t. Like that. Well, these are going to expand. We can expand these out. So I'm going to factor out an e to the at. So now I have my null solution is going to be e to the at times, we're going to have a bunch of stuff in the parentheses. We're going to have C1 times, and then let's expand the exponential. This is going to be cosine bt plus I sine bt plus C2. Now we have minus I, so this is going to be times cosine of, I'm going to do this verbally, we have cosine of minus bt, but since cosine is an even function, the cosine of bt is equal to the cosine of minus bt. So just this becomes bt, cosine of bt. The sine is an odd function, so it becomes minus I sine of bt. Now, let's regroup these by cosines and sines. So I have e raised to the at times, I'm going to have a c1 plus c2 cosine of bt plus, then I'm going to have C1 times I minus C2I sine B t. Now, this is going to feel a little odd. The first one won't, but the second one will. C1, we're going to do this. Let C1 plus C2, we can let it be some other we could do a capital C, or sometimes you'll see a tilde sign over it. So we'll just call it C1 tilde. And C1I minus C2I, we're going to call this our C2 tilde. I know it's an imaginary, it's the imaginary component of a number, but it's still just a number, and the initial conditions will sort themselves out. So look at what we have. We've got this as C1, and I'm going to distribute e to the AT. No, we'll do it later. We'll do it in 2 steps. E to the AT times C1 tilde cosine BT plus C2 tilde sine BT. And then usually the exponential is included, so this would be C1 tilde e to the AT cosine BT plus C2 tilde e to the AT sine of BT. And that would be the general solution with complex roots written in terms of the exponential and of sines and cosines. In the next video, we're going to work through an example. I hope that helps, and thanks for watching.